Hi guys, so next we will be solving the problem of insert, delete and get random in constant time. Yeah. Okay, so we have to design a data structure that supports the following operations in average of constant time. Insert a value if not already present. Remove an item from the set if present. Returns a random element from the current set of elements. It's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. Okay, I think we can use a random function to get the random number. But what the problem is, okay, I think we can use two data structures over here. The first one is a The first one is a map which maps one particular element to its particular index in the vector. So whenever we are told to insert, we will check if this exists, if this entries exist in the map or not. So more specifically, we can use an ordered map of integer, right? So let us say this is the map, and we will also create a vector of integer the y. So let us define some private parts, and this both will come in the private section. Right. So whenever we need to initialize, do we need to do anything? Yeah. So let us say that we clear both the values. Now, suppose we want to insert. So we will check if this value is equal to m dot n. Only then we will insert. Right. So the what we will do now. So now what we have to do is we have to insert this element into the vector. So what we will do is, let us say int size. So currently it is 0. So right, so what we will do is, yeah, whenever we are if this is equal to n, that means okay, m of value is equal to sz plus plus and dot push underscore back, and we are pushing back this value, and we will say okay, we have returned it. Okay, we have inserted it, else we will return 0 because we were not able to insert. Now similarly with the case of remove, in the case of remove is that, so if this value is not, that means it exists, that means we have to remove, and if we have to remove, then what we will do is m dot, so we will remove this key, and then we will decrease the size, and so also we have to remove this element from the vector. Okay, so how we will remove this particular index from the vector in constant time? So that will not be a constant time operation, that will not be a constant time operation. Okay. So we also, okay, so it's okay because it should be a constant in average. Okay, so what I can do is, right, so we will erase this, and then also, yeah, now we need to get the random. So we know the size currently, so what we will do is we will say okay, int. Okay, so how the random works, Do we need to import it? An integer. Okay. So, and we will return the num. Can we do it without the vector? Because at the end we require vector only because we can return every element with the equal probability. So I think let me check it. I'm not. Let us see if this works. First of all, we are inserting GetRandom. So we said we will insert 0, then we will insert 1, then we will remove 0, so we have only 1. Now we will insert 2, then we will insert 2. Okay, so we have 1 and 2 right now, so then we remove 1, so we have 2. So then since we have 2, the expected value should be 2 because we are just removing one element. Okay, set contains the specified element. So I think yes, this should work fine. Okay, um, it should be size plus 1. No, I think I'm making a small mistake over here. We will figure out quickly. So the standard output is 1. Since we just have one element in the set, and therefore just print out this, right? That's the issue, that we are having a 1 and we are not having a 2. Let me think what is happening over here. This valve. Okay. Oh yeah. I think first of all, the we are inserting at the zero, size becomes one, and zero comes in the set. Then we are inserting a one, then size becomes two. Then we are removing a zero, so the size becomes one. But whenever we are removing something, then the indices of all the other elements have been changed. So the entire point of keeping the indices in the map becomes useless. So let us do one thing. Instead of let us use so what we can do is, so the entire game is spoiled because whenever we are trying to remove something from the vector, we are getting an error. And also this erase function takes order of n times, so ultimately we are going to fail. So what I'm thinking is, so basically if a value is present, then we need to delete it from the array. So what we can do is, we know that deleting from the end of the vector will take constant time. So what we can do is, we know that m of value represents the index of the element which we want to delete. So if m of, so basically we need to first check if value is, so basically we will swap it with the last element, and then, because the ordering in the vector is not important for me, so if this value is equal to v dot back, so if the value is equal to v dot back, then it is easy, we can simply, and also we can simply erase. But if the value is not present at the back, then what we will do is, this is the back element, so its value will be equal to, no, this value is equal to v dot back, and also m of, no, at this index we have this value, that is okay, but also we need to say that the index of this is now index which is equal to this, and then we can pop from the web, right? So what we are doing over here is, so let us say we have an array of 1, 3, 5 and 8. Now we want to delete 3. So what we said, that the index of 3 is over here. At this particular index, the element which is present in this 8, we dot back, and then we will delete this 8. Right? So how we are doing this? Then we are saying that also the index of 8 is now the index on which 3 was present, and then we are deleting the 8 from the back. That means we are swapping the index, swapping the element which is present at the last index. Yeah, and then we are erasing the, this is okay, this is okay. I think now we are good to go, and let us run the test case. So yeah, this was a nice question from this point of view. Let us try to submit it. So this is also a constant time operation that we have done. Just a second. Yes. So this runs in constant time. Swapping is done in constant time. This runs in constant time. Yeah, we are assuming that insertion, this find function, all works in constant time for map. The lookups are in constant time. No, yeah. So I think with this we end the question, but there is a follow-up question which I saw over here. So let us see, if what if there are duplicates, right? So um, this is another, this question is for another day. The probability of each element being returned is linearly related to the number of same value under the question. So yeah, this question is for another day, but yes, we will solve it. So that's it from my side for now. See you in the next video.